Now let us see some problems in hyperbolic functions. That is here given as find Laplace transform of t cube in cos ht. Ht comes with it's a hyperbolic function. We must know what is cos ht first. Cos ht equal to e to the power of t plus e to the power of minus t divided by 2. So this is my f of t power n. So I have to use the theorem number 2. So that is Laplace transform of t power n into f of t equal to minus 1 whole to the power of n d power n divided by ds power n into f of s. Is it clear? Now I see here Laplace transform of t cube cos xt can be written as Laplace transform of t cube into e to the power of t plus e to the power of minus t divided by 2. Now let me simplify this inside the bracket. Laplace transform of 1 by 2 is out, I take L by 2, that is Laplace transform 1 by 2, I take outside 1 by 2, t cube into e to the power of t plus t cube into e to the power of minus t, that is I multiplied by t cube inside. So this can be written as 1 by 2 constant into Laplace transform of t cube into e to the power of t plus Laplace transform of t cube into e to the power of minus t. Now keep it as equation number 1. Now what I am going to do? I am going to define it again, f of it again, t to the power of n into f of t. Now I take it as f of t and I find f of s and replace back in the equation number 1. So this can be written as, first let me consider this image. When I consider e to the power of t, is it clear? Laplace transform of e power of t, I will find it. This becomes 1 divided by s minus 1. That is e to the power of at formula is what? 1 divided by s minus a. And Laplace transform of e to the power of minus t, this becomes 1 divided by s plus 1. So this 2 I got it. Now what is my intention? This is my f of s, right? Replace f of s here. This is my f of s, right? Replace for this question, that is. So equation 1 implies 1 by 2 into Laplace transform of t to the power of n into f of t. F of t I have taken separately. L of f of t I found it 1 by s minus 1. This becomes f of s. So using this formula, using this particular formula, I am going to change that. This becomes minus 1 whole to the power of n. N means what? 3 into d cube by ds cube into f of s is what? 1 by s minus 1. Plus the bracket minus 1 similarly whole cube into d cube divided by ds cube into f of s is what? 1 by s plus 1. Is it clear? So now 1 by 2 into minus 1 whole cube means minus d cube divided by ds cube. Now I am going to differentiate 3 times 1 by s minus 1. We know that differentiation of 1 by x is minus 1 by x square. Similarly, if I go for differentiation of 3 times, that becomes minus 6 by 1 by x power minus 6 by x power 4. Similarly, I consider this as x. So if that is the case, minus 6 by s minus 1 whole power 4 plus minus into minus of 6 divided by s plus 1 whole to the power of 4. Now in the simplification, the next step, 1 by 2 into minus into minus becomes plus, so that becomes 6 divided by s minus 1 whole to the power of 4 plus 6 divided by s plus 1 whole power 4. And I take outside 6, this becomes 3 into 1 by s minus 1 whole to the power of 4 plus 1 divided by s plus 1 whole to the power of 4 is the required solution. Okay guys, let me discuss some different types of problems on Laplace transform derivatives. Now let me consider this problem. Evaluate integral 0 to infinity t cube into e to the power of minus t into sin t dt. Now look at it, so many things in this problem here. T cube into sin t separately comes means we know how to solve this problem. But something is coming integral 0 to infinity and e to the power of minus t. Okay. Now how to solve this type of problems? We will be seeing that. Let integral 0 to infinity t cube into e to the power of minus t into sin t I will write as integral 0 to infinity e to the power of minus t into t cube into sin t dt. Now let me consider this. Let me find the Laplace transform of t cube into sin t. After finding Laplace transform of this, I am going to substitute back in this equation. Get it? So I will be keeping this as 1. So now Laplace transform of t cube into sin t. We know how to find Laplace transform of t cube into sin t because it's in the form of t to the power of n into f of t. So first you are finding f of s for f of t and you are taking that and replacing in this particular formula. This becomes minus 1 over cube into d cube divided by ds cube into f of s. Now my intention is to replace f of s in place of my intention is to replace f of s here. So now let me find f of s. F of s is Laplace transform of f of t, that is Laplace transform of sin t. So what is Laplace transform of sin t? We know that a divided by 1 a divided by s square minus a divided by s square plus a square, that becomes 1 divided by s square plus 1. So now this is f of s replaced back in this previous equation. When you are replacing that, this implies what Laplace transform of t cube into sin t implies minus 1 whole cube into d cube divided by ds cube into 1 by s square plus 1. Now I need to simplify step by step. Now what will be there? It will be minus 1 whole cube means minus 1 into d cube. I can write d cube as d by ds of d by ds of d by ds into f of s 1 by s square plus 1. Becomes minus d by ds of d by ds of, now I differentiate this becomes s square plus 1, differentiation of 1 is 0, minus 1 is constant as it is and keep as it is, yes, this becomes 1 into 2s divided by s square plus 1 whole square. So this becomes minus d by ds of d by ds of, when I simplify this becomes tends to 0, this becomes minus 2s divided by s square plus 1 whole square. Is it clear? So now minus into minus plus, this becomes d by ds of d by ds of 2 is also constant. If I take 2 outside, no issue. If I take 2 outside, so this becomes s divided by s square plus 1 whole square. Is it clear? So now this will be taken to next step. So this becomes 2 into d by ds of differentiation of s by s square plus 1 whole square. So this becomes, as usual, u by v format I am going to use. This becomes s square plus 1 whole square into s differentiation is 1 minus s keep as constant, s square plus 1 differentiation, s square plus 1 differentiation will be 2 into s square plus 1, again s square differentiation is 2s divided by s square plus 1 whole to the power of 4 I will be giving. So this becomes 2 d by ds of so this implies 2 into d by ds. Now I am going to simplify this clearly. So So this becomes s square plus 1 whole square minus s into 2s square into 2, that becomes 4 s square into s square plus 1 divided by s square plus 1 whole power 4. Now what is common for me here? S square plus 1 whole square, x square plus 1 I have, x square plus 1 I take outside. If I take x square plus 1 outside, I will be getting d by ds of s square plus 1 minus 4 s square divided by s square plus 1 whole power 4. So 1 s square plus 1 x square plus 1 will get cancelled. It remains as 2 d by dx of 1 minus 3 x square divided by s square plus 1 whole cube. Now what I need to do? Again I need to go for differentiation by using u by v format. Now we got 2 into d by ds of 1 minus 3 s square divided by s square plus 1 whole cube. Is it clear? So now I am going to differentiate it using u by v form. This is u, this is v. You know that u by v, differentiation of u by v equal to v into u dash minus u into v dash divided by v square. So that becomes s square plus 1 whole cube into minus 6s. After differentiating 1 minus 3s square, I will be getting minus 6s minus 1 minus 3s square into differentiation of s square plus 1 whole cube. This becomes 3 into s square plus 1 whole square into x square differentiation is 2s divided by s square plus 1 whole power 6 v square, right? So v is s square plus 1 whole cube, that becomes whole square I done with s square plus 1 whole power 6 I will be getting. This becomes 2 into, now simplify this. In this, what is the common? You take it. Now I can take, look at it, s square plus 1 whole square if I take outside, and s also I can take outside. What will be the left out inside? S square plus 1 into minus 6 into minus 6 minus of 1 minus 3 s square, 2 3s are 6. So this is my left out portion. One I have taken s square plus 1 whole square into s outside. I have taken s square plus 1 whole square into s outside from this complete numerator. So this becomes s square plus 1 whole to the power of 6. Now s square plus 1 whole square and whole square get cancelled and left out with 4 here. So this becomes 2 into s into, look at it, s square plus 1 whole square will get cancelled. Is it clear? So 1 2 will get cancelled, 1 4 will left out. S into s square plus 1 into minus 6 minus of 6 into 1 minus 3x square divided by s square plus 1 whole to the power of 4. What I got it now. Now again I simplify here. 2 into, let me simplify completely. Yes, as it is, minus 6 into s square minus 6 s square into minus 1 into minus 6, that becomes minus 6 minus 6 again minus into minus plus 18 s square I will be getting divided by s square plus 1 whole to the power of 4. I got it. Simplify this. 2 into s plus 18 square s square minus 6 square, it becomes 12 s square minus 12 divided by s square plus 1 whole to the power of 4. So this simplification will be, look at it, 12 I take outside again, 12 into 2, 24 s into s square minus 1, which I got. 12 I take outside, s square minus 1 divided by s square plus 1 whole to the power of 4 I will be getting it. Is it clear? Now how can I write it? Finally, solution. How to proceed to solution? This is what L of t cube into sin t. What I done now. That's what we got it. 24 s into s square minus 1 divided by s square plus 1 whole to the power of 4. Now we know integral 0 to infinity e to the power of minus t into t cube into sin t, what we have into dt. To write this, first let me write a standard form of this. The standard form of integral 0 to infinity e to the power of minus st into t cube sin t to dt. I can write it as 24 s into s square minus 1 divided by s square plus 1 whole power 4. So now compare this standard equation with what I have in the question. This is e to the power of minus 1t, this is e to the power of minus st. Therefore, what is my s here? 1. So, by replacing s equal to 1, by replacing s equal to 1 in my answer, what I got now, that implies 24 into 1 into 1 minus 1 divided by 1 plus 1 whole to the power of 4 is equal to 0. So, finally, you got it that integral 0 to infinity e to the power of minus t into d cube into sin t into dt equal to 0. This is the complete solution for the given question, integral 0 to infinity e to the power of minus t into t cube into sin t dt. So now we will solve one more problem. Now let us solve integral 0 to infinity t into e to the power of minus 3t into cos 2t into dt. Is it clear? This is my problem what I have here. So as it is what I done last problem, similarly I will consider it as it implies integral 0 to infinity e to the power of minus 3t into t cos 2t into dt. First what I am going to do, I am going to take this t into cos t separately. This implies Laplace transform of t into cos 2t I will be finding first. This you know, t to the power of n into f of t. You know what is the formula? T to the power of n into f of t is minus 1 to the power of n d power n divided by ds power n into f of s. So I need to find first f of s for given f of t. My f of t is cos 2t. So Laplace transform of cos 2t I will be finding first. This becomes s divided by s square plus 4. This is what I got of s f of s. Now take this and substitute back this for the Laplace transform of L into cos 2t can be written now minus 1. What about t power n here? T power 1, that is n equal to 1 and d power 1 ds power 1 into f of s is what? S divided by s square plus 4. That means I need to differentiate only one time. This becomes minus d by ds of s divided by s square plus 4. Now let me differentiate this minus u by d for my v into u dash, right? S square plus 4 into u dash means 1. S differentiation with respect to s is 1 minus s u is keeping constant and s square plus 4 differentiation I am doing 2s. 4 differentiation is 0 and v square I will be getting as s square plus 4 whole square. So this is what I got my solution. Now again s square plus 4 minus 2s square divided by s square plus 4 whole square. So this can be written as minus of minus s square plus 4 divided by s square plus 4 whole square. So this can be finally I will be getting s square minus 4 divided by s square plus 4 whole square I will be getting it. Now this I need to take it for integral 0 to infinity e to the power of minus 3t into t into cos 2t into dt. Let me consider this. Now let me take in the standard form. Let me take it in the standard form. This becomes integral 0 to infinity e to the power of minus st into, I will be getting as integral 0 to infinity e to the power minus st into t cos 2t into dt is equal to s square minus 4 divided by s square plus 4 whole to the power 2. Get that? So now this becomes, now compare my s to the standard. What is my s here? 3. E to the power minus st is, I will compare with e to the power minus 3t. So I will be getting as e to the s equal to 3. By replacing s equal to 3 in my standard solution, this becomes 3 square minus 4 divided by 3 square plus 4 whole square. So this becomes 9 minus 4 divided by 9 plus 4. That becomes 13 whole square. So this becomes finally 5 divided by 169. This is your complete solution for the given problem.